In Finland, the properties of various components of wood have been studied for a long time. But the global pandemic has brought increased urgency to this study. Face masks, now a huge waste challenge, are mostly made from fossil-based raw materials. Replacing them with biodegradable materials would effectively address this waste problem. In addition to biodegradability, wood-based alternatives could also provide a natural path in the fight against bacteria and viruses, without damaging those microbes that are useful and important to us.
So actually the problem with many of the current solutions is that they are generally toxic. They kill all the bacteria. And the worst case scenario is that they don't kill all the bacteria, they kill all the good ones, because the good ones are usually easier to kill than the real toxic ones. So then these toxic ones have freedom to grow. So this is like the worst case scenario of using these general methods.
Plants have evolved over millions of years to resist assaults by bacteria, fungi, and viruses. Some key antimicrobials are incorporated into the structural carbohydrates of plants. At Aalto University, Monica Österberg's group has studied the properties of lignin and cellulose nanoparticles in combating the spread of pathogens.
What we are researching is that we are looking into making different kind of coatings that could be used on textiles or on tables as a cheap and also a natural antimicrobial coating.
Our main focus have now been in this bacteria that causes hospital infections, this MRSA, and we have found out that some of Monica's products are able to kill those, but are not necessarily harmful for other microbes, because, well, world is full of microbes that are not harmful at all, and those we don't want to kill.
Plants also have various classes of secondary metabolites, for example, polyphenolic compounds that perform many functions, including the killing of pathogens.
Because the trees need these compounds also for their own defense, so they need to fight against different pathogens, fungi, other organisms attacking the trees. And usually these compounds are located in the bark of the tree, so it's kind of a shield against these nasty pathogens.
Currently, wood bark is not utilized in higher value-added products.
At the moment, most of the bark is still used for energy production in the industry, so we could use it in different cascade processes to first obtain these active compounds and then use also the rest of the biomass for different purposes before it's finally burned for energy.
In a large, recently established research collaboration at LUK, the Natural Resource Center of Finland, these compounds are currently being developed for commercial use.
We have found already very promising results of different tree extracts, and the extracts have been tested and shown activity against different virus types, including enteroviruses, which are really nasty ones to kill, also with ethanol-based disinfectants. And then we have found activity against the seasonal coronavirus and also the virus which is causing this current COVID pandemics.
In a recent publication, the team at LUK has mapped the entire process of creating extra value from bark.
We have studied this kind of cascade processing, where the idea is that we first, for example, extract valuable polyphenols and other water-soluble extracts out of the side stream. It can be, for example, bark, and then they are utilized for high added value products. And then the remaining biomass can be still used for other processes. So we are kind of combining different unit processes together in order to get most out of the raw material. And after the extraction process, the residues have been, for example, taken to the slow pyrolysis process. And from that process, we can get out of tar and we can get biochar and then pyrolysis liquids. And those liquids are kind of a residue which can again be directed to biogas process, AD process, and from that we can get out of biogas, for example. and the solid residues can also be directed to this AD process. By this way, we can get really most out of the raw material.
Findings related to these wood properties have already been applied commercially in Finland. For example, bio-based disinfectants and antimicrobial coatings have recently entered the market, and they can be used, among other things, to treat textiles.